Me and Bastian will now continue to do our video on this assignment that we did, and I will start by explaining the part A of the exercise 1. And so before even jumping into the questions, we need to mention that um, we will only explain our approach and our main thoughts of how we solve the questions, but we do not go into in depth with the calculations and all the things because we don't have time for that. So yeah, let's just start with the part A of the exercise 1, and this is about using the first principle to find the derivative of f of x at x is equal to -1. And to do this, our approach will then be starting by finding the difference quotient for f of x, and then find the differential quotient, and lastly use the differential quotient to evaluate f prime of -1. So yes, step 1 will then be here finding the difference quotient for f of x, and we did a lot of calculations, and we then came to this expression for the difference quotient, which is the most simplified one. And afterwards, we use this difference quotient to find the differential quotient. And to do this, I've established some conditions or some conditions here and some definitions. And I will now say that I will now investigate what will happen to the difference quotient when h approaches 0. So when h approaches 0, h becomes insignificant because it becomes infinitely small. And this means we will have this expression down here, which is the differential quotient. And now I will use this differential quotient, which is of course also the slope of the the slope of the slope of the point of tangency, the slope of the tangent. And to do this, we will just view it as f prime of x sub 0 and replace x sub 0 with -1 to evaluate f prime of -1, which is 4. So the derivative of f of x at x equal -1 is 4. Yes.
Yes, so to account for f of -1 and f prime of -1, we need to note that f of -1 evaluates the y value of f of x at x is -1, whilst f prime of -1 evaluates the slope of f of x at x is -1. So we evaluated both of these, and we found that with f of -1, it was equal to -4, and f prime of -1 was equal to 4. So this means that the y value of f of x at x is -1 is -4, whilst the slope of f of x at x is -1 is 4. So to find the equation of the tangent line to the graph of the function f at the point where x is -1, we need to remember or note that the equation of a tangent line to the graph of the function f at an arbitrary point of tangency can be described with this expression right here. And when we observe this, we will find that x sub 0 is equal to -1. And these values of f of x sub 0 and f prime of x sub 0 are of course taken from the calculations done in assignment B. And now when we assert these values into the formula and simplify, we find that y is equal to 4x, which means that the equation of the tangent line to the graph of the function f at the point where x is -1 is therefore y is equal to 4x.
Lastly, which is the part D, is about finding the point at which the graph of the function has a horizontal tangent line. And before I take the problem, we know that the slope of this point, this horizontal tangent line, will be 0 because it is horizontal. And after that, I will differentiate f of x and find the corresponding x value to the slope 0. And this x value will then be the point of tangency, the x value to the point of tangency of the horizontal tangent line to f, the function f. So now I differentiated the function using those rules here stated. I got this expression, and now I'll find the corresponding x value to when this function has a slope of 0. Corresponding x value will then be as calculated here 1, and to evaluate the y value to the point of tangency of the horizontal tangent line to f, I will just evaluate f of 1, which is f of x sub 0, and the result will then be f of 1 would be 0, which is the y value to the point. So we can conclude that the point of tangency at which the graph of the function has a horizontal tangent line is therefore at the point or ordered pair 1, 0.